So let me demonstrate how to do Gaussian elimination without writing too many things down. So I'm going to begin with the system itself. So x minus y plus 2z equals to negative 3. And I'm going to write down the second equation, x plus 2y plus 3z equals to 4. And then finally the 2x plus y plus z equals to negative 3. And here's what I'm going to do. I'm going to write a massive arrow and I'm going to put a new system right there. So on this arrow, I'm going to explain what I'm planning to do. So again, first step is to remove that x right here. In order to accomplish that, I'm going to multiply the first row by a negative 1 and I'm going to add it to the second row and I'm going to put it back into the second row. So that's what I'm planning to do on this step. Now, the first row is not going to change at the end of the process because the only thing that's changing is the second row. So I'm going to go ahead and write down the steps, write down the first equation, write down the second equation, the third equation, and for the middle one, I'm going to do the stuff mentally. So I'm going to multiply the first equation by negative 1, so that would give me negative x plus y minus 2z equals to positive 3. And the second equation is already x plus 2y plus 3z equals to 4. So I'm going to do this stuff mentally, and once I do it mentally, I'm just going to write down the answer into row 2. So if I do it mentally, what do I get? The x's go away. 2y plus 1y is going to be 3y. And then negative 2z plus 3z is going to be 1z. And then finally, 3 plus 4 is going to be 7. And typically speaking, this stuff gets deleted at the end. We don't need it. So now you can see my system looks a little bit better. The middle equation is missing the letter x. So next we want to focus on removing the 2x. So how can we remove the 2x? So we're going to write another massive arrow. And again, the way you're going to remove the 2x is like this. You're going to multiply the first equation by negative 2. So the row 1 gets multiplied by negative 2. Then add the solution to row 3. That's the one you want to cancel, and put the answer back into row 3. So in this step, the only row that's changing is row 3. So everything else is going to be copied right away. So I copied the steps, I copied the numbers down right away, so that way I don't accidentally forget one of them or make some sort of a silly mistake. So the first row is not changing, the second row is not going to change, the third row is going to be changing. And how am I going to change it? I'm going to change it according to the rule. Multiply row 1 by negative 2, add it to row 3. So let's try to do that mentally. Multiply row 1 by negative 2, and we get negative 2x plus 2y minus 4z equals to 6. So I'm taking the row 1 and I'm multiplying it by negative 2. Then I'm going to write down row 3, which is 2x plus y plus z equals to negative 3. And now that I've done that, let's go ahead and add them up. How much do you get when you add them up? The x's go away. We end up with 3y minus 3z equals to 6 minus 3, which is 3. And again, you're done with this mental stuff, so you're going to go ahead and delete it. So far, this is what my system looks like, and I'm going to go ahead and keep going to the next step. So what's the next step? The next step is to remove that 3y. So how am I going to do that? To do that, I'm going to multiply the middle row by negative 1 and add it to the third row. So the middle row gets multiplied by negative 1. So row 2 gets multiplied by negative 1 and add it to row 3 to give me back the answer that will go into row 3. Okay, so the answer that I get is going to be placed back into row 3. Since row 3 is the only one that's changing, I'm going to keep writing the first row and the second row. And once I write them down, I'm going to do the step mentally. So multiply the middle row by negative 1, and I get negative 3y minus 1z equals to negative 7. And then add it to the third row. So, the third row is negative 3z. And then equal to 3. So add them up. These two cancel out. Negative 1z, negative 3z becomes negative 4z. And then finally, on the other hand, negative 7 plus 3 is going to be negative 4. And I'm finished with this mental stuff, so I'm just gonna delete it. So this is my system, and it looks now the right way. The middle is missing the x, the final row is missing the x and the y. So now what I have to do is figure out what the z is from that third equation. Once I know the answer, plug it into the second equation to get the y, and then once I know the y and the z, plug it in the first equation to get the final answer, which is x. So here we go. But wait a second, if I know that negative 4z is equal to negative 4, then I would know that z is actually 1. All I did is divide both sides by negative 4. But then I can put that into the second equation, and since z is now given as a 1, I can plug it right there and figure out what the y is. So 3y plus 1 times 1 is going to be 7. So this means that 3y has to be equal to 7 minus 1, which is 6, which means the y is going to be 2. So now I have the y and I have the z. All I'm missing is the x. So use the first equation. And so the first equation tells me what the y is, and it tells me z. I know what the z is, and I'm gonna put equal to negative 3. And so again, I'm plugging in the y as a 2 because that's the number I got, and I'm plugging 1 for z because that's what I got. So this is basically x equal to negative 3. And now I'm completely done with the problem. So the solution here is going to be the x comma y comma z. So negative 3, 2, and 1. So like I said, the calculator can take you from the very first step here all the way to the answer right there in one shot. All you have to know is what to plug in and what to hit on the keyboard to get that answer. So that's the reason why I'm kind of going through it quickly and I'm not explaining it very, very thoroughly, because ultimately we're going to be getting this answer from the calculator. I just wanted to demonstrate a couple times how to do it without a calculator, so that way you could kind of be aware of what kind of process the calculator is solving for you. It's basically saving you from a lot of headaches. But what I do need from you is to know what this notation means, right? What this notation over here means. That's something important that you need to know, please.